Okay. So good morning, everyone, again. Assalamualaikum warahmatullahi wabarakatuh. So thank you very much, Mr. Winsun, for your kind introduction. I will share my screen now. So for today, we have 4 speakers to be together with us for this AI and robotics workshop. And we are very fortunate. We are very fortunate to be here today together with all of you as part of the team for this MEITA events. Okay, our group is under the MEITA Robotics group, and today I will be sharing the introduction for robotics and AI. And later, our team we have brother Hazwan, and we also have brother Ridhwan, and also Mr. Winsun. Okay, brother Winsun. So let me start for the introduction. Later, the details of the concept of how we're going to develop our technology, and hopefully some of the insight that we want to share today will be part of the uh, element that you're going to learn, okay? And also maybe it can be implemented. So this session is recorded, so it can be viewed later through our website, MEITA website. So as the introduction, I would like to share with you what is CAIRO and what we do. And we are under the Center for Artificial Intelligence and Robotics. Okay, so the topic today is very related to the center itself. And we have 2 offices. One is in Kuala Lumpur and the other one is in Johor Bahru. Okay, and I am mainly available in Johor Bahru, but then as the office is in Kuala Lumpur, so we having our main activity as well in Kuala Lumpur. So I have to travel roughly once a week in Kuala Lumpur. This is our member. I'm the director, and we have around 8-9 members, together with the administration staff. So maybe around 12 to 15 staff. So the center itself is a competence center under MEITA. So we were being awarded as one of the competence center back in 2019 under MEITA Competence Center, and it was managed by the Mohd, Ministry of Higher Education. And we ourselves is one of the Center of Excellence in UTM. So the vision of the center is to lead in the area of robotics and AI for good of mankind, and we want to see how we can lead in the area of frontier intelligence system for industries. We want to share and disseminate knowledge, information like what we have, what we are having today in this event, and later on to provide our solution to the society. So the fundamental aspect of research that we do together with the member is categorized under 3 main areas of AI, robotics, and control. And currently for the application, we have field robots, agriculture, healthcare, and smart manufacturing, and also others. But these are the 4 main areas that we are focusing on in the application side. So today I will be sharing some of the work that we have, mainly in A2 Lab. Okay, A2 Lab is another lab, so it's a subset, I can say subgroup under CAIRO. So I am the head of the lab, and all of our speaker today is coming from A2 Lab. So I am proud to introduce later our 3 speakers to share their work, and also to introduce you for the detailed part of some of the things that we have in the lab, and it should be related to the competition that we are going to go for this event. Actually, I'm wearing this hackathon shirt. So as part of the promotion of the program, last time we also organized Hack for Good event together with Ericsson, and also involved in the same team of mangrove, connected mangrove. And in this event, we see that there are different kind of solutions available, and some of it are working in the area of IoT, some of it are working in the area of connectivity, in different application, for example, in water quality, or in the biodiversity element, and few other areas. So I believe that this experience will be good for all of you. And if you are interested in AI and robotics on seeing how this application can be applied, so maybe we can see some of the work that we have done to be part of the inspiration of your work. Okay, so biodiversity is also part of the area that we are working in MEITA. Okay, so first of all, I would like to share how does a mangrove swamp or mangrove area look like. Okay, so this is the aerial or bird eye view of the mangrove available in Malaysia. And we understand, I think from yesterday, there are talks also on the importance of mangrove ecosystem. We have a lot of biodiversity, flora and fauna available, and how the mangrove is also protecting our benteng, our border, the sea and the land area, okay, of our peninsula and also Borneo. So we want to start with this drone aerial flight video. Can you? This is a video that was taken in area of Langkawi, if I'm not mistaken. So you can see how beautiful the area. So we have the hillside at this right-hand side here, and we see the mangroves area covering some part of the ground area available. So in this mangrove area, you can see a lot of, if you go down deeper, so on the ground side, we have maybe crabs, we have a lot of other animals that uses some of the food ecosystem, okay, to live and also to do its own habitat activity. Okay, so these are part of the thing that we can see what are the problems or what are the issues that we want to play our role in applying AI and robotics. Because we also have other kind of technology. For example, we can use sensory system using IoT and connectivity, and I think that part will be covered by Professor Adwati group. So she will be highlighting on how IoT sensory systems can be used to also answer some of this problem statement. Okay, so this is how a mangrove swamp or mangrove area looks like. And yeah, the best experience that maybe I can highlight is if you can go yourself and we have some activities to do seeding so that you can feel and see how the process of growing mangrove, okay, to do activity of conservation. So I would like to start with AI activity, AI technology that is very related to robotics, okay. So this is few examples of how AI is coming in our daily lives, where AI can be used with the vision perception. So where we have cameras that can detect human, for example, when we have movement or motion. So then we see the camera will be getting the image, or maybe we can do manipulation, counting, and so on. So you see some of the object which is not moving, then it will not be taking its giving any borders, okay. So no action are being taken if there are no motion. Okay, I think some of you have seen this apa game tu? What was the apa cerita tu? Squid Game ke? So on how the detection of the human were being detected by the doll kan. So that is also part of AI element that involved. All right. So next, we see using AI, we can also analyze. Okay, for example, this is cars moving, or car or trucks moving from right to left and left to right. So the bottom line, the bottom road here is cars moving from left to right. Okay, from my screen, left to right, and here is right to left. Okay, so once we want to do detection and we put a threshold line, okay, so we can see the numbers of the car moving either left to right or right to left, we can do analysis on it. Okay, we can count. So let me play again. Okay, you can see how fast the system can calculate. Even our bare eyes have difficulties, because if we have only right to left motion, I think we can easily count, but then we have both now, left to right as well. So I mean, human have limitations, but then for system like AI or robotics, I mean, once we train them, then they can do something which will be better. Okay, and third, we can also recognize. Okay, for example, just now we just identify any movement of human or movement of vehicle. Now we can recognize, for example, between a car and a truck. Okay, how big is the percentage of accuracy? Okay, for example, here you can see the percentage of accuracy is more than 80. So the higher the value, we can understand that the more accurate the data will be. And later, I think Wilson will be sharing some of this method of how AI works in doing some of this kind of detection. Because we have some fundamental aspects on it, okay? So the perception, the neuron, and so on. And AI can also be integrated, okay? Just now we see static camera or static image, no, static input, okay, from video feedback. When we have videos or perception from image to be working together with actuation. So then here we can see one application of a drone where if we want to do autonomous landing, so then using the AI part, then we can understand how the system will be moving left, right, left, and so on. So action-based system is also possible. And we have a lot of solutions nowadays that can be combining both AI function and also robotics movement. And we can see some of the work that was done under CAIRO together with researchers, for example, Dr. Zul later, on how we use a drone together with AI perception to do some of the application in agriculture. Okay, so I would like to start with this implementation. Okay, the usage of AI and deep learning. Deep learning is part of AI. Okay, we have machine learning, deep learning, a lot of different algorithms, fuzzy neural network. So it is under the AI family, and this is how we integrate and work together with robots such as drone. Dr. Zul published his work in this journal, Applied Science, on deep learning sensor fusion in plant water stress assessment. Okay, so for every plant, you have to be having either three main important lah. So you have ada two main sun, and also tiga lah. So sun, yang kedua dia punya carbon dioxide, ataupun kita need oxygen, they need carbon. And the third one is water. Okay, kalau tak ada water, kita pun boleh mati juga kan. The same thing for plant. So the water stress level can be detected using AI, and this is how Dr. Zul uses his deep learning sensor fusion to analyze the plant water stress. Okay, so on measuring the soil moisture estimation, the soil water modeling, the evaporation, and then the forecasting of the evaporation, and how to plan to see on the water status estimation. For example, if you go back to your hometown, suddenly you forgot to manage your gardening ataupun plants ke, so when you come back from your hometown, nanti tengok mati semua. Okay, so how to automate those systems, so we can have a combination of IoT sensors, or we can also use some of these robotics element to do the actuation to spray the water. Okay, but this project is using drones, okay, to do the data acquisition and management of the field data. Okay, next, another work that was done is on low altitude quad rotor for plant growth monitoring system. Okay, just now we see on the water stress management. Okay, and if we look for the first project on mangrove, this is not mangrove lah, this is banana. So different kind of plants will have different, I can say, lifespan or maybe the apa sturdiness, because for bananas ataupun some of the tree memang kena ada air yang cukup. For example, palm oil ke ataupun mangrove ke, mungkin dia very robust. Okay, you tak siram banyak air pun dia boleh untuk hidup. Okay, so depending on trees, so then we have to know if we want to study on the water stress management for mangrove, for example. So what will be the information that we need? Is it going to be in the first phase during the seeding process ke? Ataupun bila dah besar, I think we don't have to consider more on the water stress management because mangrove itself is very kata robust kind of plants. So we have to ask the expert lah if you want to do on this water stress management analysis. So second, I want to go for the plant growth. I think this is one of the area that can also be a problem statement. Okay, this is an example of using drone. So drone is also part of robot, and we use image based. Maksudnya we have like a camera, and from here we can identify the location, the altitude, latitude, and so on. And from the image, we can understand what will be the growth rate. For example, the first flight that we have, for example, in the first month, and then later on we can come after 3 or 6 months and we can see and measure the growth of the trees, and we can do analysis. Ada masalah ke, ada monyet kacau ke, because we identify that one of the thing yang mangrove ni dia very sensitive adalah dia punya pucuk dia. So kalau kata ada siapa-siapa yang kacau pucuk mangrove, then the growth of the mangrove itself will be terbantuk lah. So this second problem statement of plant growth monitoring is also important, and it can be applied to mangrove as well. So currently, from my understanding, we have some expert on mangrove highlighting that currently how they do measurement adalah manually. So dia ada macam ada satu, I don't know, sensor that they use to measure initial data, and then come back later, we can measure another second time. So we can propose drone maybe, or we can also use mobile robots. Okay, mobile robots can also be used. Having the same concept, we have some laser distance, for example, and then using the image, then we can know the growth rate of the trees. So I think not only quad rotor can be used, mobile platform can also be used. So while we go for this kind of different projects, hopefully it can be giving you some insight. Just that you have to relate with mangrove. Okay, you have to see and understand what is the growth rate of mangrove within 1 or 3 months. Ada banyak beza ke tidak? Or maybe we can put it like 1 year, 2 years kind of monitoring process. Okay, that part you have to go through lah. Okay, the third project that was done also by a group of Dr. Zul is to look at the large plantation area. Okay, large plantation area. So we see using AI and also drones. Okay, we can do AI assisted livestock counting. You see in the beginning of the video, the beginning of the slide, I show you examples of how we do for cars and for vehicle. So not only cars, once we do the training, okay, we understand and we annotate the actual object that we want to analyze. Then later we can have the model, and from the model we can do the manipulation. So the line here is the threshold. Once the cow pass through the line, then we can have how many numbers of the animal are being counted. So AI ni dia ada limitation juga. You have to do a lot of training. So the model will decide. The better the higher the accuracy will be representing the similar values of the actual. So that's why we have to do validation. Okay. So on mangrove side, how we can look on the items. For example, if you want to plot how many trees per area, so we have to do AI imaging, and then maybe we can have like identification of aerial, I can say, view of mangrove. so that from there we can calculate, for example, in this 1 hectare area, how many mangrove trees are available. So it is also possible to be done together between AI and robots. Okay. Another project that was done is on deep learning for image-based disease. So I'm not sure whether a mangrove ecosystem need to be analysed. For example, biasa for any trees, the challenging part is the dia panggil seeding process yang masa nak membesar. I think not for trees lah. For us human pun sama, kan? So kita daripada kecil lahir, lepas tu kita merangkak dulu, and then kita nak kena jalan dulu, and then baru kita boleh berlari and membesar. So during this early years, 5 year and below, our parents are looking care for us and then very orang kata menatang minyak yang penuh lah. So the same thing for plants. Okay, biasa untuk nak memastikan dia boleh hidup, mungkin the time span will be shorter. Mungkin sebulan ke, ikut bergantunglah. Salad mungkin dalam 1 minggu, 2 minggu, because 1 month tu dia dah boleh matang, dah boleh terus kita makan. So it depends on different kind of vegetables or maybe plant. So the same thing for mangrove. Okay, just that here, this is a study that was done using for paddy. So we can see how analysis of AI can be used so that we can detect diseases. Okay. Last time when we do our field survey together with IoT team, so they put cameras, static camera, and they take time stamping. Okay, time stamping tu maksudnya continuous. For example, for 1 day, 4 times. But then during this time stamping, we can see the low tide, high tide of the water coming in. And also we can identify siapa yang datang kacau, okay, pokok-pokok. So one of the conclusion, because we identify some of the area tak boleh hidup dengan baik. So we detected ada monyet yang datang untuk makan pucuk-pucuk. Then this tree tak boleh membesar, okay, compared to the other area. So this is the example of a problem statement, because for example for IoT we can do detection, tapi the manipulation process tak boleh nak buat lah, tak boleh nak halau ke ataupun nak buat something yang boleh menakutkan keluar siren ke. So these are something that we can also do integration between sensing part and also the control part, the manipulation. Okay, so this is also another examples of how AI and also robots are being used. So this is to do detection of, for example, analysis of bananas with covers or without cover. So you can see how many yang ada in one area lah. Okay, with static camera macam ni. So what is the data that can be taken? So then the drone can go from one area to another, then it will do the detection. So this is the process of how AI and robotics are going to be integrated together. And hopefully you can think of something. We have to ask the experts of mangrove later how this technology can be used and it can be part of problems that we can solve. All right. Okay, let's move on. This is another aspect which is not related to plant or maybe animal, but this is for assisted asset monitoring system. Using AI and drone, we can do detection of fences. So whether the fence are working or not working well. So I think, for example, if there are some conservation area that we want to protect, so we can see what are the element that we need to do on the asset management as well, not only on trees. Okay, so maybe we have to ask people in Sijangkang, do they have, like, for example, area that need to be protecting from any human to come in? Okay, so probably if it is a real problem statement, then solution of how drone and also AI can be used to monitor those assets together. Okay, so it's up to you guys. You have to do some literature comparison. I think some of you already have titles, but then to refine your work. Okay, so hopefully our sharing today can be part of the inspiration. Okay, using IoT is one way to do water quality monitoring, but then actually another method of looking for water quality can be also done by using observation. Okay, water quality here, they have a lot of ways. One of the way that was done by, this is by Dr. Ibrahim. they were studying on the alga identification. Okay, and from the color of the water, we can do detection of how severe, okay, the condition of the water. So if you look at the previous video that I show, the water was very, very clear, clean. So we can see, yeah, data coming in. Okay, IoT can come in to do the static analysis, but then if you want to do dynamic analysis, or maybe this kind of solutions can also be done. Okay, part of the idea. Okay, next, we go for robots. Okay, this is some of the work that we have in our lab on using robotics. And as I mentioned to you, we have aerial vehicle that we show the examples earlier on integration with AI or integration with sensors. Mobile robots can also be used. Okay, if you have some of your work that you do in mobile robots, but we have to know that the area of mangrove, it is not as similar with the grass area ataupun the tar that we walk together through our with vehicle tak ada. Swamp area with high tide, low tide, it is very muddy. Okay, so the selection of your locomotion ataupun tire ke track ke, it is very important. Later, maybe Brother Ridhwan will explain some more details of some of these components, and we have some use cases that we can highlight on some of the robot that we have. So this is example of how we do for underwater robots. And different robots have been developed, and it will be based on what problems that we want to solve. So for this underwater robot, we highlight the issues of maintenance and also the issue of cleaning. So you can see here how the maintenance of the water tank are being done and how our solution will come in. Okay, but for mangrove, you have to identify what are the problem statement that you want to solve and how your solution is answering for the pain point that you are highlighting, right? So this is just to highlight what are the examples of work that we have done. And using robots, we can do it for collecting dirt. And I believe it is not suitable if you want to have this solution in mangrove area, because what kind of cleaning that you want to do, right? I think it's better for us to concentrate on the inspection and not for cleaning purpose. So one of the thing I think in the pitching session later, they want to see how you convey your ideas. So for example, if you have a prototype, if you have a design, and then if you have tested some of your work, if you have a mangrove area around you, that will be the best. If not, then maybe you have to prepare a props, okay, something to show how your system can actually provide a solution, and maybe if you can get some feedback from the people on the site, that will be the best. Okay, so this is an example of how we do the development, and later we go to the site and then we meet different people, not only in water tank, we also go for other kind of tanks, for example, in agriculture area, so how robotics can be used. So I want to show you the overall idea when we want to propose, okay, any solutions throughout this competition. You have a problem statement, what will be your objective, what will be your method to achieve your objective, and how you want to convince the panel later on your solution, okay? So having a prototype would be good, having a design will be good, depending on your scale of team that can provide the solution. If you can go and test it at the site, that will be the best, okay? So and to understand well how your solution is really solving the issues. Okay, I think my time is quite limited. Okay, I want to skip here. These are all the videos that we have for the robots. Okay, okay, so this is the new robot that we have. Okay, if you see here, the old robots is a gray in color, so here is the black in color. So some of the development and improvement that we do, for example, now we have a front and back camera to do analysis. So once we have the first prototype, we see the problem, then we can also do improvement based on the previous problem. So I think for our hackathon today, your stage will be at the first stage. Later, if we see the idea will be good, so it will be best for you to improve and try to see how it can be actually implemented. at the site. So this is the first robot you see here, the gray color here. Okay, and this is the new one that we have developed to improve. Another robot that maybe can come out of your mind if you have interest in, so we can also develop something like this, bio-inspired robots. Maybe you can put sensor on this. I don't know. We can think of something that can do monitoring. So that people have been developing artificial fish and artificial drone to observe areas, because sometimes if you have the actual drone flying, then maybe the birds will be afraid of this artificial, I mean the actual drone. But if you have a drone looks like a bird, so maybe they will think of, okay, this is our friend, huh? So then they will not run away. So then we can go and observe the conditions closer. I think there are videos that I'm not sure from which sources, National Geographic. So a hummingbird drone are being developed by a group of researchers, and then they go through an area where they have a very big habitat of butterflies. Okay, and the footage that was taken is very close to the habitat of butterfly, and you can see how the butterfly are attached together, and yeah, how they behave in the area. So this kind of bio-inspired robot is also part of ideas that we can give you. So if you have, for example, you want to study on crabs, I don't know, this is just an idea, okay? So then maybe we can develop a crab robots, okay? Or I don't know, if we want to study on living creatures underwater. So this kind of robot that we can do, put in some cameras, put in some sensors, then we can do some analysis of behaviors. Because the higher number of creature that we have, the better the biodiversity element that we can detect in this mangrove ecosystem. Okay, okay. Winsun, can you hear the voice for this video?
No, I can't hear the voice of the.
Can I hear? Okay, tak apalah. I think the okay, this is a video that was together with Adibano. They came to our lab, and we share some of the work that we have in the underwater robots. So this is the ROV. We call this ROV angler, the green one for to do inspection. And then this is the first version of, not first version, this is the third version actually, but this is the ROV Pleco to do the inspection and also cleaning the tank. So Adiba came, and then she tried to manipulate the robots and see how the robot is moving. And from here, we also highlight that some of the thing that we can do is to train. For example, we want to do detection for turtles. Okay, so when we highlight this application, we also mention using drones, we can detect images of apa cows ke ataupun kambing ke. But then for underwater, we can use this underwater drone. Okay, underwater drone can be used, and we can also implement AI in it. So we have this robot that we also went to different kind of stakeholders, possibly to use in different areas, and we do inspection, different inspection, underwater inspection, for example, dog inspection in MMHE. And one good thing is, other than the dog inspection, we also observe the flora and fauna. So we can see different kind of animals, macam obo-obo pun ada. Okay, and we also did study to detect turtle, okay, dekat Tanjung Tuan. Okay, and I'm not sure Tanjung dekat turtles ni ada ke tidak dekat area mangrove. So expert can answer that. Saya rasa tak ada lah. Mungkin different kind of underwater creatures ada. But then underwater robots can be used. Okay, if we want to implement with AI, then we can do, for example, counting ke, we can do the size detection ke. Maybe we can ask some of our mangrove experts to share what are the problems or what are the analysis that we want to do. So we can come out with our solution. Sorry, I tekan escape. Okay, I have exceeded my time so that I can give some of other explanation to our next speaker. Before I go, okay, Brother Ridhwan will be sharing some of the work that we do with robotic later with this robots, adapting robots. So I just go and skip through because the detailed explanation Brother Ridhwan will be explaining and how we have tested. Okay, this is the validation process, and the panel will be amazed if you have your solution to be tested. Okay, so that's why I show this example so that if you can plan your time, our pitching date will be on 15 December. What kind of test or validation that we can do? Okay, and that can be part of marks in the rubrics for the evaluation. Okay, as best as you can. Okay, as best as you can. So I think with that, I would like to thank you for joining this session. So later we have Brother Ridhwan, Brother Hazwan, and Vincent to share their next talks on robotics and AI, and hopefully you can get benefit of this sharing. And I think some other possible areas to explore. You can apply computer vision in mangrove robotic swarm, like what I shared earlier. Applied the previous one was applied in ladang lembu tadi kan. Maybe you can see how what kind of problems that we can see. We can measure the tree height. We can put robots with sensors. We can construct map of the area and count maybe the number of trees or mangrove tree. Explore seedling, aerial planting or maybe mobile planting. Sebab nak tanam mangrove is not easy. And biasa kita pergi pun kasut kita pun boleh terlekat dekat dalam lumut, bukan lumut dalam apa tu, lumpur tu. So you can come up with different kind of problems or maybe to distribution, fungicide distribution to protect mangrove, aerial surveillance for illegal deforestation. This is example of ideas. Okay, if you have your own idea on how you can use your solution, that will be good. But then please confirm and validate it with some of the experts. Okay, in MEITA website, we have a lot of collaborators together, so you can contact and ask them to validate your ideas. So with that, thank you for your kind attention. I would like to pass back the session to Mr. Winsun. I'm very sorry for taking extra time. Okay, Winsun, back to you.
Okay, thank you very much, Dr. Athif, the Prof Athif. Yeah. So now, our next speaker is Muhamad Hazwan bin Abdul Hafidz. He's currently pursuing his PhD in University Technology in Malaysia. He was a process engineer working with Foxconn for 2015 to 2017, and he is currently the lab head for our actuation and automation lab. So previously, he was a trainer for Academy of Science Malaysia for this teaching design flow, and he is mainly engaged in the research field of pneumatic artificial muscle control. So without further ado, let's welcome our brother Hazwan to our talk. Hazwan, sorry, we can't. You're currently muted.
Oh, sorry.
Okay.
Thank you, Mr. Wingsun, for the very kind introduction. Okay, so for my part, I will be presenting project formulation. So now allow me to share my slides, please. Okay, are you able to see my my slides now?
No, Hazwan, unfortunately, we're looking at your browser.
Okay, what about now?
Yeah, now we can see it.
Okay then. Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good morning to Prof and also all the audience on the floor. Okay, so for today, my topic will be project formulation. Okay, so firstly, I think most of you have been involved or engaged in some type of project. So I would like to ask the floor if any of you know what project formulation is? Does any of you know or have any idea? Maybe. Okay. So no problem, because as you can see, even the robot in the photo is also confused because I haven't started the presentation. So today I'm going to present about my topic, which is project formulation. So project formulation is actually the process by which we obtain a complete picture about the project without actually having detailed feasibility study. So in other words, it's part of the project cycle where it is the project planning phase and also the rough project planning phase. Okay, so the project formulation that we will follow is a simple design methodology with simple steps that we can all follow, which is named the design flow. Okay, so these are the 5 simple steps of project formulation, how you are going to formulate your project at initial stage until where we start from emphasize, and then we go to define, ideate, we create a prototype, and we test the prototype. So I think for your pitching session, this is the process that you will be doing. And today I would like to share about this process. So first of all, I would like to share about the importance of why you need to follow the design flow. Okay, not only for your marks in your pitching, but for any type of project. Maybe you are going to do mechatronics or robotics development, or even if you apply AI tools and utilize the data to come up with predictions. So we are going to follow this simple process. So the importance, what's the importance of following these steps? Okay, when we start a project or when we develop a project, a product, we have to keep in mind that our final product should be a product that is very useful for the end user, has to be very useful for the end user. The end user have to love our product for it to be used. Okay. Secondly, the users usually have a traditional method of doing things, so our product, it has to be easier to use and more efficient than the traditional method. Only then will it be used. As my past experience as a process engineer, I had a lot of technicians that were placed under me, and for my experience doing a lot of projects, I have done a lot of award-winning projects there in Foxconn Technology. Those projects that are more harder to use than the traditional method will be forgotten, and those projects that are easier to use by these end users, these are the ones that will be there until I think until now. They're still using some of my projects because they are more easier to use than the traditional methods, and they are also more efficient. So that's why we need to follow these steps.
Well,
Okay, and
we
another
cannot
thing.
see you. Your camera. Are you switching on your camera?
Oh, I switched off my camera, Prof. Is it
Okay,
okay?
okay,
Do I
okay.
need to switch on?
Better if you can switch it on without any internet delay. Tak apalah kalau boleh on.
Yeah, because I was thinking of internet delay. Wait, I need to exit first, maybe. Um, okay,
Kat,
because I'm sharing the same screen, so
tak apa. If it's problem, tak apalah.
okay, sorry then, Prof. Okay, so another use of this design flow is to better plan your manpower and also to make sure that your project is according to the deadline. Okay, so let's go to the first step, which is to emphasize. Okay, so what is the meaning of empathy? Okay, so the definition of empathy is the ability to understand and share the feelings of others. So what you are actually doing, the first step should be to put your shoes in the user's shoes. Okay, and then this can be done by 3 simple steps, where the first step is to observe. So the first step is to go over to the problematic area and observe what is happening with your eyes. You observe, and then next is to engage. Into engage, like Prof. Athif said just now, to engage with a professional. So is to meet a professional and go into the process even deeper, uh, and to get a detailed knowledge of the process. And last of all is to immerse, which is to try out the process yourself. Okay, you can go there and try out the traditional method. What is the traditional method? And from there you can get an even deeper understanding of the process. So once you know a lot about this process and the problems that they are facing, then only you can design something that will eliminate all the problems of the previous process. Okay. So next is to, after you have empathized, you have found out about the process, then next is to define. So what is there to define? So define, first of all, you have to define the problem. As said by Prof. Athif just now, formulate the problem statement. So you have to identify what is the problem statement. Then you have to identify the project goals and scope of the product, the milestones, when do you need to submit. Maybe you guys are having your pitching session on 15 December. So you have some milestones from now until the 15th of December, and also the people in charge. So if you are in large groups, so you have to use your manpower efficiently and assign them to each of these small design processes. Okay, so we have a few engineering tools that can be used to in the define stage. Okay, first of all is the cause and effect diagram, the Pareto chart, and the run chart, and also box plot. You can use these to define the problem. And then you can use product design specification to define the project goals and also the scope, and also the Gantt chart to define the milestones and also the people in charge. Okay. So this is still in the define stage, where, as I said earlier, one of the tools that you can be used is the cause and effect diagram, also known as the Ishikawa fishbone diagram. So this diagram is a very simple diagram, but then it's a very powerful diagram, always used in the industry. So how to use this diagram? Can you see my mouse?
Yeah, we can see your mouse.
Okay. So how to use this diagram is we are going to place the problem or the goal at the end, or maybe the head of the fishbone diagram, and then we are going to brainstorm for all the types of causes for this problem. So in the causes are usually in 4M, 1P, and 1E. Okay, so usually sometimes from my experience, when we have a problem, we are always stuck, biased. We are biased to one type of cause, where if we do this Ishikawa diagram, we will expand our mind and we will find for a more deeper and more detailed problem other than the cause that we have stated. And also we can also create a checklist of what could possibly create this problem. Okay. So as I said just now, we have to define the problem. Another tool that can be used to define the problem is the Pareto chart. Okay, for Pareto chart, we need the data of the problem. Maybe we can create a survey asking this expert what is the problems, what are the problems that they are facing. And if we compile it, then we will have some kind of bar chart like this. And as you can see over here, we are to be able to identify what is the biggest problem faced. We can use the Pareto chart where you can see the biggest chunk here. If we are able to eliminate this problem, we are able to eliminate 80% of the quality issue in their site. Okay, so if maybe you have marks for identifying the problem, then this can be done in order to prove that your problem is a very serious, a very critical and crucial problem to be solved in this area. Okay, another tool that you can use is a run chart. So in order to have a run chart, you also need data. You can see the plots here. These are all data plots from the sensors, and they are giving some sort of value. Okay, I have also used this run chart before. Previously, I was working with automatic machines, and one of my automatic machine is a label printer. Okay, so this label printer has to print out, and the placement of printing has to be according to a given spec. So it can be placed higher or lower, but then it has to be within the spec. So there was one time where we had multiple rejections of this, but then this rejection was on off, So it happened for a few weeks, months actually, and my boss told me to come and see what the problem was. So what I did first was, after doing the cause and effect diagram, what I did was I created a run chart with the data. So I plot the data, and then only I found that at every point number 5, there is going to be a spike of the point. So this run chart actually is going to actually uncover things that you cannot see with the human eye. Okay, we never noticed that actually point number 5 is going to be a bit higher, and this is because of actually the raw material, where the sticker number 5 is placed 1 cm apart from the normal sticker. So this is actually a raw material issue. But what we can do from outside is that we can actually program the ladder diagram, the PLC program, to make the PMP, the pick and place, collect the label further 1 cm whenever it is at point number 5. Okay, so these are a few tools for identifying the problem. Okay, next, as I said just now, is the product design specification. So before you even start the doing the design, you have to know what is your design specifications that you want to target. So this design specification is not only formulated by you, but it's also formulated by the end user. So when you go for the interview, you have to create the product design specification with the end user. So this is because usually the experts, they know more what is the specification of the product that they need for their processes. So this product design specification is going to include the performance, the physical requirements, the cost, aesthetic factors, and also legal requirements. Well, the cost is usually everyone wants low cost, right? But some don't mind for having a higher cost if you are able to solve a very big problem. Okay, so after you have completed the product design specification, then you can start by identifying your milestones and also the people in charge. So this can be done by using a Gantt chart. Well, I think maybe some of you know that a Gantt chart is actually used by project managers, but in construction, not only in Malaysia but also in the whole world. Okay, so this Gantt chart is a very effective tool for you to monitor the progress of your teammates, and also to know where the delays are coming from, and you can push manpower to these delays. So if you have marks for teamwork, then maybe a Gantt chart is a way to display how uh, how your team work as a how your group work as a team. Okay, so next is to ideate. Okay, now that we have the problem in hand, we have the specifications that we need in hand, and also the planning for our manpower, Now is the time for us to explore the solutions. Okay, so there are many solutions to one problem, but how are we going to find a solution that is as close as the product design specification as possible? So there are some tools that we can use to explore this solution. So the first tool that we are going to use is the black box analysis, and then the morphological chart, and then later the weighted decision matrix. I will be going through one by one. Okay, so for the black box, so every product that you make is actually consists of an input, an output, and also a black box, where the black box is actually our product, and inside this black box, inside this product of ours, we are going to do something called functional decomposition. Means we are going to decompose each function of your product. Okay, so let me give a example of something I did during my degree years, where I was doing a automatic fish feeder for fisheries Gelang Patah. Okay, so the input here is the feed inserted. So they're going to insert the feed into our product, and the output will be the feed is distributed towards the inside all of the ponds. Okay, so in this box, we are going to decompose, we are going to break down the functions into smaller pieces. So we are going to be able to zoom into each of these functional processes. Okay, so as you can see here, the feed is going to be inserted into the fish feeder, and it's going to be stored in the storage area. And this will be held by the structure, where after being stored, it's going to be channeled. It's going to be channeled to the feed distributor, where this will be controlled by on-off control or any type of control. And next is the range amplifying mechanism, where we have a functioning mechanism in order to enhance the range of the distribution of the food. Okay, so this is the black box that I told you earlier. And then next we're going to go to the morphological chart. Okay, so this is a morphological chart. Okay, if you notice the black box just now, all the components in the black box are all here in this column. So we have the storage, we have the structure, we have the feed channel, feed distributor, the control, and also the amplifying mechanism. So what we do in the morphological chart is we are going to lay out as many options as possible for each of these components. So let's say for storage, we have many types of storage. We have this kind of storage, and we have this kind. We have also the funnel kind, and also the fishbowl kind here. And for structure, we have many types of structure that we can use. We have ABS, aluminium, all with different properties. And then we have the feed channel, the distributor. There's a lot of ways of distributing. We have the pump. We have centrifugal force by turning of the mechanism. We have catapult. So we have a lot of options for each of these functions. So by doing this, we are able to select. We are able to not be biased to only one option. So if you see how many options we can use here, how many as this is actually a part of concept generation, so we are going to use the morphological chart to generate concepts. So we can take option 1, and then we can put it with option 2, and then we can go back to option 1 here, and then we can go to maybe option 3 and option 4, and then we can go to option 3, and this will be the first concept. This could be the first idea. So as you can see here, there's about 4 and 5 or 6 rows here. So we can actually produce thousands. Actually, we can produce thousands. I think about 4,000 plus for this set. If we have 4 options, we can produce thousands of ideas for our design. So this is a way that you can show that you have gone through a lot of designs, and later we will select which is the best design, or maybe not the best, but most closest to your product design specification that you have set with the user. Okay, and how do we do this? We evaluate the concepts, we evaluate these ideas by using a weighted decision matrix. Okay, as you can see here, these are the designs we have. We can put here as many designs as we want, but then usually we come up with a few designs which are most logical to use, and then we are going to weight them according to their performance. So then our performance here is range of feed, low cost, storage, and also feed timing. And the one with the highest score, this one here should be the one that is closest to the product design specification. Okay. Okay, so this is a case study of one of the projects that I conducted during my degree years at Project Ternakan Ikan Marine dalam Kolam Tanah, PPK Johor Bahru Selatan at the Fisheries Department of Gelang Patah. Okay, so as you can see here, this was the first step, which is empathize. Okay, I came here to observe first. So what I observe is, as you can see from the third picture over here, you can see the worker distributing the feed into the pond. And if you can see here, this is the feed that he needs to carry. So he uses a wheelbarrow. He puts a lot of these packs into the wheelbarrow, and then he brings them here at a very hazardous situation. He moves on this very small line here to distribute the food into the ponds. And as you can see here, there are about maybe around, I think, 25 ponds here that he needs to distribute the feed into the ponds. So this is my observation. So next, I went to have an interview with the expert. And what I found out by having the interview with the expert is that not only does he need to carry the fish food, but he has to distribute the food to all parts of the pond. So he is going to go all around the pond and throw in some fish food to all these parts of the pond. And there are certain regions in the middle here that he is not able to reach. And for the nature of the fish, from the words of the expert, from the nature of the fish, these fishes they live in groups of less aggressive fish and also aggressive fish. So if you give food to one region only, then there is a possibility that the less aggressive fish are not able to have any food for the day. So that's why they need to round the pond, and this is a very very unergonomic and also a very difficult job to do for the workers, since they have 25 ponds. Here, right? Okay, so I formulated my Gantt chart because I wanted to finish in time. And I also design my product design specifications from the knowledge that I have gained from my interview, from my observation, and also from my my tryouts of trying to throw the fish food as far as possible. But I couldn't throw it very far into the middle of the pond. It takes quite effort to do so. So I designed my product design specifications with the users, and for my final, the automatic fish feeder should be able to cover a wide range of feed spread. So previously it could only cover 20% of the pond. If I am able to go above 20%, then this is already a win for my design. Okay, next, each time they throw the feed into the pond, for one pond, usually 7 kg is needed. So at least for about 4 times of feeding, 30 kg is enough for the automatic fish feeder. Next, they want minimal cost, and they want the distribution of the feed to be every 12 hours. Okay, so before this, the traditional method, they don't do every 12 hours. They do once in the morning and once also in the evening, because it's very dangerous to do it at night. So by having an automatic fish feeder, we are able to eliminate that problem also, where we can give it 12 hours, which is the most ideal time. Okay, so as I said just now, I designed the black box, and this is the functional decomposition of all the functions in the black box, and the morphological chart that I presented just now. As you can see, the arrows show my formulation of concept. So we can go from storage and then to structure here, option number 3, and then we can go to option number 4. We can even skip if we want. This is merely by a guide. Okay, this is merely by a guide. You don't need to follow it too strictly. Okay, and then we choose this as the feed distributor and this as the control. We use sensors, and then for the range amplifying mechanism, we are going to use rail tracks, and then we can also form other types of ideas from the morphological chart. Okay, so by doing this, you can form a lot of different ideas that you can later choose by the weighted decision matrix. Okay, so this is a sketch of a few of my ideas. So this is a sketch of a few of my ideas that I generated from the morphological chart. So you have idea number 1, 2, and 3 here. I had a few more ideas, but I'm only showing 3 here. Okay, so the first idea, you can see this one here is going to be placed in the middle of the pond, and then we are going to use centrifugal force in order to distribute here, and we are going to be using a motor over here. And then you have the pump one here and the rail with the rail tracks. So this one here, we only need one of the machines to circle the whole place. Okay, and this one here is also using real tracks, and also there are also a lot of other methods. Okay, so next is the concept evaluation using the weighted decision matrix. So we weighted all these. As I said just now, the range of feed, according to the product design specification just now, the range of feed needs to cover more than 20%. One, the storage to be at least 30 kilos, and also the feed time to be what's it called, to be distributed 2 times per day. So we are weighting this according to the product design specification, and the highest score is the one that will be chosen. Okay, so this is a way to prove that we have formulated a lot of ideas and we have chosen the best design. Okay, with the most efficient design, the most best design according to the product design specification. Okay, so this is the final concept. Okay, I skip a few parts here because after you have chosen the design, then there is the analysis that needs to be done, the mechanical analysis, whether the pump is going to cover the desired range, whether the structure will able to withstand the weight of the feet inserted, and also the breaking the points, the critical breaking points, which points need to be enhanced. And after that, this is the final concept of the automatic fish feeder. Okay, so this is the prototype that we made. This was done in order to actually try out or test out our circuit. We made an automatic circuit that feeds twice per day, and also to see whether the distribution of the feed will be just like as we simulated, to validate our simulations. Okay, so that's all for me. So a more detailed explanation on mechatronics, robotics development, and also AI basics will be presented later by Brother Ridhwan and also Mr. Wing Sun. Okay, so thank you.
Okay, thank you very much, Hazwan, for your talk. That was very enlightening. I myself have learned something from it. And also I want to share with you our next speaker here will be my friend, Mr. Ahmad Ridhwan bin Muhammad Kamil. He has received his bachelor's in engineering from University Technical Malaysia, Malacca, and is currently pursuing his master's of philosophy in Malaysia Japan International Institute of Technology, MJIT, in UTM. He's engaged in the field of robotics and mainly on mobile robot, and currently his research on mobile robotic navigation system. He is a member of our A2 lab, and when he is attached for research work, and he previously has received a gold award in exhibition competition for industrial art and technology exhibition in Athif, and he's currently a trainer for autonomous mobile robot development and robotic operating system, ROS. So let's welcome our Mr. Ahmad Ridhwan.
Okay, thank you very much, Mr. Wilson, for your kind introduction. So, allow me to share my screen.
Hazwan still sharing your screen, Hazwan?
Yeah, Prof. I am trying to unshare, but then I'm not able to. Okay.
Okay, now it's okay. Now
Okay.
it's okay.
So, can everyone see my screen?
Yeah, okay. Clear one.
Okay, so first of all, let me introduce myself again. My name is Ahmad Ridhwan. I'm currently a master student under Prof. Athif. I'm also a member of the lab also. So I will be sharing a talk about robotics design. So before that, let me just a brief introduction on the history of the robotics. So the history of robotics, I think already a long time. I think it's been a few decades already. So what the most significant is on the 1962 from the General Motors is that they installed a Unimate as the world first robot on a production line. Unimate then launched Puma, the world first six-axis articulated robot, which led to a new generation of flexible manufacturing system and more technology in robotics nowadays. So another significant of history, actually, another one is by the Stanford Research Lab. So this is a mobile robot. The name is a Shaky. So this is the world first mobile robot that are able to reason about its own action. So that means that this robot they are able to perform an autonomous tasks such as planning, route finding, and also re-engine of a simple object. So in short, we can say that Shaky was the path maker to today's intelligent robot. So this is just the brief introduction of the robot. So the one in the first one is for the industrial in production line. Another one is for more like a mobile based robot. So what available currently today for the robot? As you can see on the most left side, I think this is the quite famous robot from the Honda Asimo humanoid robot. So and on the right side, you can see the articulated manipulator robot, such as the robotic arm from the universal robot, from the KUKA, and also in the middle one from the Omron is also a combination of the two type of the robot, which is mobile and also the manipulator. And also there's some like a legged robot, mobile legged robot, which is from the Anibotics, like a dog one. And also the Omega one is the most likely like an autonomous mobile robot, like a automated guided vehicle (AGV). So this is the currently available in the market that company have provided. Any company have provided. So from that we can generalize the type of robot. Actually, we can assume there's a two type of robots. The first one is actually the typical manipulator, which is mostly we known as a robotic arm. So the robotic arm is actually mainly operated in a constrained workspace. So the sensor and also the movement have the absolute measurement of the position. And also sometimes the robotic arm may or may not need to perceive the world around them. So in generally for the production line, sometimes they only do a repetitive task. So in very highly concerned workspace, so they just use the programmable task. And another type of robots is actually a mobile robot. So typically, mobile robots is a type of robot that can be moved around the environment. So this robot mainly can be operated in unconstrained environment, and it's also required external sensing to determine the position, and also the sensing part to sense the environment and also the avoid the obstacle. So this is the picture of the Mars rover from the NASA. So this is a example of mobile robot. So for this sharing, mainly will be focusing on the mobile robot. So actually we can generalize the type of mobile robot. Actually, a robot that can roll, walk, fly, or swim. So this one here on the left side, you can see the underwater robots, the some kind of like and then agriculture robot, and then the legged robot, and also like a humanoid robot, and also drone. So on the next, I will be sharing how the case study of how we design a robot and also a project, how to define the locomotion of the robot, how to decide the locomotion of the robot. So, and then this is type of the robotic sensing that available that we can be used to put in our robot. So, as an example, we have the depth camera, and then we have a LiDAR sensor, which is a laser-based ranging system, and also we have the IMU sensor. So to get to sense the orientation of the body. So any information of the robot collect about itself and environment require sensing. So for the mobile robots, the important thing is how to move from one position to another position and then collect some data, and then to do some maybe some learning, maybe to do some AI to collect data to go as example to know the growth of the tree, something like that. And then all sensor also have some degree of uncertainty, and this uncertainty we can reduce by use multiple sensor and multiple measurement, and then we can do some filtering, and then we can get a very high accuracy. So next we'll be going two things on the sensor. So sensor can be divided into two type. So one is for proprioceptive, another one is exteroceptive. So proprioceptive actually is to know its own state, such as, so if we have the mobile robot that use motor, we need to know what is the speed of the motor, what is the current voltage of the motor, and also the angle of the joint angle, and etc. Another one is the world exteroceptive. So let's say that everything environment around the robot, let's say for the temperature, let's say for the obstacle around the robot, and so maybe some type of humidity, and maybe some pollution gas sensor, some sort of. So actually there's a two type of sensor. One is active, another one is passive. So the example of the passive, example of the active actually it has some kind of energy that to produce to measure the sensor. Another one is passive. So example of active is actually it's like a LiDAR sensor, which is it use projecting the laser, and then from that laser we will know the distance of the obstacle. And for passive, we can say that it's actually just sense the environment such as a camera. So on this uh, sharing session, I will be using my previous project, which is the dark inspection robot. So I will be using my previous project to do some case study on how we develop the robot from start to prototype testing. As we can see from the project flow just now from the other Hazwan. So this is also quite similar with the flow presented just now. So first thing, we have to know our problem background and also our statement. What is the problem that we want to solve, and also what is the environment of that problem. And the next one is we have to define our scope and also our objective of our prototype. And the third one is we have to do some design and also development to solve all the problem. And also lastly is after finish up the design and development, we need to do a prototype testing to validate our product or prototype. So first, let's go on the problem background and statement. So as I told just now, we will be using the dark inspection robot as one of the case study here. So let's check the problem background of this issue. So firstly, a contaminated HVAC system is more prone to spread biological and non-biological. So the background is here is that the unclean and unmaintained duct can spread pollutant throughout the building, and also from that it can causing a symptom called sick building syndrome, or in short SBS. So actually in the Department of Occupational Safety and Health also have guideline in their Industry Code of Practice on Indoor Air Quality 2010 conclude that inspection and cleaning have to be done for HVAC system regularly in order to maintain the indoor air quality. So this thing is true, especially on the healthcare department, where if I'm not mistaken, in healthcare department, they need to be inspect twice a year and clean one time a year. So this is actually quite a valid problem background. So next we will be going to a problem statement. So what is the problem right now for to do this inspection? So as we know from the picture, the hatchback duct is actually, if on the big building, the duct is very big, and also it's quite small for a human to inspect directly inside the thing. So due to the hidden of the complex of modern ventilation, sometimes it's hidden in the ceiling. So we require some kind of suitable robot to inspect inside the thing. And also because of the thing is too big, and sometimes we need to inspect on a large area of that thing. So sometimes when we bring the robot inside that thing, we also want to know which part of the which part of the duct is actually need to be cleaned or need to be maintained. So it's hard to locate the robot in the ducting. So from this segment, we're able to produce our objective. So from this, we can define our objective. For the first objective, actually we have to design suitable duct inspection robot. So later on we will see what is our decision on designing the suitable. So second is to integrate simultaneous localization and mapping with this duct inspection robot. So previously we want to know the exact position of the robot when doing the inspection, and also we also can do some localization and also a mapping with this integration. And then lastly, we want to validate the functionality of our prototype. Is it can be used in the real on-site testing? So that is the three objective for this case study. And then for the project scope, we have to scope our project that is not too big lah. Too big. If too big, the scope is very hard also to achieve. So our scope is more on the hatchback duct environment is only considered as a case study, and also as part of the disadvantage of the mobile robot, so only we perform on the main duct, which is only horizontal duct environment. Next, we go on the prototype design and development. So the whole project is mainly, we can assume that is mainly consists of two parts, which is hardware and also software. So by combining these two parts, we actually can produce a functional air duct inspection robot. So for the first one, we'll be looking at the hardware design and development. So the type of locomotion that we decided to choose is actually this differential drive robot. So what is actually the differential drive robot? Differential robot is actually a two-wheel drive system with an independent actuator for each wheel that can actuate. So the drive wheel usually placed on each side of the robot, and the motion capability of this type of locomotion is actually a straight line motion, and also we can also rotate in place. So this rotation can be done by driving the wheel at the same rate on both of the motors and at different direction. So here we can see the drive wheel, and also sometimes we need to support with a non-driven wheel. We call it as a caster. So the decision to use this kind of differential drive system mainly because first thing is it is simple to control, and also the control can be implemented using a unicycle model. So next we will be going for the unicycle model of control. Unicycle model actually we can assume as the direction of the velocity and also the rate of the angular velocity. So in a global coordinate frame, we can represent the velocity of robot as a x dot, y dot, and theta phi dot. So how we get this from the this formula? So when we want to control something robot, we want to say that okay, robot, we need to go front 1 meter per second, and also we need to rotate like a 0.5 radian per second. So how actually we can convert it from that command to the velocity of the each wheel of the robot? Actually, we can use this simple unicycle model. We can calculate the velocity of the each independent wheel. So here you can see on the below one, VR and VL is actually velocity of the right wheel and the velocity of the left wheel. So by using this model, we can control the mobile robot using this method. Okay, so for the component selection, this is some of the initial hardware design. So firstly, we have one microcontroller. We have one set of motor, including with the encoder, and also one Raspberry Pi, and another one is actually the LiDAR itself for do the simultaneous localization and everything. So why we decided to use this because mostly I think all of this component actually I think is readily available at a low cost. And also this system use a 3-cell battery. Okay, and then let's take a look on the software design and development. So this is generally the system block diagram of our software. So as you can see, actually we have two parts on the robot side and also on the remote PC. So let's take a look on the robot first. So we have, I think, quite only few number of components here. Firstly, we have a LiDAR, we have a camera, we have the Raspberry Pi, Arduino, motor driver, and also encoder. So how actually we are controlling the system actually? So Arduino is mainly used for controlling the motor and also reading the sensor from the encoder to know the exact velocity of the each tire, each wheel. And also the Raspberry Pi mainly used for the high level control, which is to integrate with the LiDAR and also camera. So, and then we have another part of the component here is actually our remote PC to visualize our map, to localize our robot, and also to control the robot. So the connection between the robot and robot PC mainly use the internet connection. Or I think for local network, we just use the local network Wi-Fi. So the component that we use is actually the software for the SLAM, actually the SLAM toolbox itself. And then our tele operation keyboard to control the robot and also a display to visualize the camera. So firstly, when we design the robot, so normally firstly we will design in SolidWorks, and also it's a good practice if we can make a simulation first before we continue on fabricating the actual robot. So what I did here is actually I designed the mobile robot in the SolidWorks, and then I convert it into a simulated robot. So the simulated robot use the format is not called Unified Robot Description (URDF). So mainly most of the simulator accept this kind of format, and we can simulate the robot. And then after we finish, we can fabricate also the actual robot. The same thing with also with the environment. For this case, we just use some simple ducting like environment. So we create also on the SolidWorks, and then we also convert it into the simulated environment. So the simulator that I'm using here actually from the gazebo, and also I also fabricate the actual one, not actual lah, the mock-up of the design in the lab. So I just use some low cost wood, plywood, to the shape. So what we can see here actually in the in-lab testing. So this is some demonstration for the testing part inside the lab. As you can see here, the robots are able to make inspection, and also we can also know the position of the robot from using the simultaneous localization and mapping. So let me play it again. You can see. So here is the robot. You can see here the robot. We can track the position of the robot real time, and also we are able to make a map from this software. So we can know what is the shape of the thing and so on. So after we have developed and we have tested in our lab, so we bring it to on-site. So this is some of the on-site testing. Actually, this is on the real thing. So as you can see here, from the camera we can monitor the condition of the inside thing. This is just some picture of me during the on-site testing. So I think that's all for me for this sharing session. If any of you have any question, maybe can ask me.
Okay, thank you very much, Ridhwan. We can have, because I think we already have like around nearly 2 hour session. It's good that if we can open for any question and answer first before we go for the final talk by Winsun. Can we open Winsun for Q&A session? And we can have like a 5-minute break as well.
Yes, and if any questions for my part just now, the project formulation, you can also ask now.
Yeah.
Okay, so let's open the session for a Q&A. And and then afterwards we'll take a 5-minute break. So let's start the Q&A session now. Any of you have any questions? You can just unmute your mic and ask, or put it in the chat.
Okay, I think I saw one question in the chat. So why do I need two microcontroller, right? Actually, I just use one microcontroller. Another one is the single board computer. So the mainly I use for why I decided to use another microcontroller. One thing is that the Arduino microcontroller I use actually mainly for the encoder reading. As we know that the Raspberry Pi is unable to do some fast interrupt. So because of me using quadratary encoder, and the resolution of the encoder also quite high, so we have to use the microcontroller to get the data for to get the fast response of the interrupt. And also why we need to use Raspberry Pi also, mainly because of the camera, and also mainly because of the LiDAR. Camera and the LiDAR use USB connection to interface. So the only choice that we have is actually to use a single board computer. So I think this is quite a common practice that people use to integrate with the LiDAR and also camera.
Okay. Any other question? We have 41 member here. If no question, then maybe we can give 5-minute break. Until we can start back what time? 11 maybe? Or 10:55?
Yeah, let's start
So the
at
last
10:55, Doctor.
Okay, so our last session will be from Winsun to share on the AI part, and that will be our last session, and we can have like final Q&A session before we go. We can finish before 12, inshallah.
Okay. I would like to remind everyone not to leave yet because afterwards we will be
Yeah.
giving out the attendance form, and after you fill it, there'll be a certificate given out to all the participants here.
Yeah. So please stay with us until the final session. We have the final session after this on AI. Okay, thank you. We will meet you back in the next 5 minutes. You can have some break, and we will meet at 10:55. Okay, see you.
Is everyone ready? Okay. So let me introduce myself. I will be your speaker today for AI basics in the project introduction. So my name is Hong Win Sun. I received a master's in mechatronic and automatic control in University Technology Malaysia, as well as in computer vision and robotics from University of Burgundy in France. And currently, I am a research assistant working together with Dr. Athif in this MEITA project. And my field of research is mainly in 3D printing, soft robotics, computer vision, as well as AI. So without further ado, let me share my screen. Second. Okay, can everyone see this? Can everyone see my slide? Okay. All right.
Yeah. Okay, can.
Okay. So let me share. So this is my topic, AI-based project basics and introduction. So this talk is mainly to give you a head start, give you an introduction on what about AI projects and the basics of it. So first of all, usually we want to ask ourselves what is AI. So AI is basically the ability for machines to mimic human-like intelligence of behavior. So things like learning, planning, perceiving our world, as well as interpreting information around our world. These are all artificial intelligence usage. And the thing is, usually we don't pay much attention to all of these kind of things, but it is actually a very important aspect, and it's quite hard to be implemented in a computer or machine system. But the thing is, AI itself is really popular nowadays, but it's not a very new field. It's actually quite old, and this started back in 1950s, and it only gained popularity today due to the rise in computing power, and more specifically for our GPU. So with our GPU has more power, it is now gaining a lot more popularity. And some of the popular aspect of AI is deep learning, machine learning, as well as fuzzy logic. So when we talk about fuzzy logic, this is an interesting part. Most of you probably use fuzzy logic uh, almost every day or throughout your life, but you never realize it. So where is this fuzzy logic used? It's actually used in the washing machine. So you may not realize this, but when you look at fuzzy logic on the washing machine, that's basically a small one of the aspect of AI. So basically, you already have an AI system on your washing machine, but you probably never realize it until today. All right, next, I'll go to the next slide. So you can see in the 1950s and the 1970s to 1980s, the AI is mainly on basic pattern recognition, where the early machine is actually trained to do simple tasks such as recognizing shapes and patterns and whatnot. But as we progress from the 1980s to the 2010s, it starts to go towards machine learning, where the machine is able to make statistical inference to make better prediction. So it's able to predict more and start to learn more. And then finally, we have our new one, which is start at the 2010s, which is called deep learning. So this thing actually, the AI is actually imitating a neural network in our brain. And this thing, so the computer system is trying to imitate how the human brain thinks, and this is more specifically the neuron, how it thinks. This is what this is what the field of research that is so hot about right now. So basically, it's just trying to trying to implement human thinking in on robotics and machines. Okay. So all of these started actually from the invention of the perceptron from Frank Roosevelt, which is designed to imitate the neurons of the human brain. And this Frank Roosevelt is actually a psychologist, I can't remember. But yeah, he actually invented this later on because he wants to find what is the most he wants to he wants to design a very what he wants to design the simplest method that the human brain is able to interpret something, is able to learn and interpret something. So he built this perceptron, and this perceptron becomes a network. And early on, we see here, is a perceptron is something like this. So how does it work? Is that when you have input, which is a certain value, it will be multiplied with a certain weight. So this is also a value. So basically, x1 will be multiplied by a certain value, and all of this will be summed together, and then it will go through a step function. So what a step function is basically a function where once it exceeds a certain threshold, the neuron will fire. So this is very interesting because this imitates our human brain. Because in our human brain, if when you want to feel pain, you want to feel touch, all of this are actually happening in our neurons, where the neuron have to exceed a certain threshold to be able to fire out, and then this one will send a signal to your brain and say that, "Ha, I'm feeling pain," and that's how the neuron works. And if your neuron is not firing out the signals, you will not be able to feel the senses such as pain and whatnot, pain, touch, and whatnot. So it's very important for you to understand that this is the perceptron, and this is how it works, because this will be the basic building block in a neural network. And why do I say that? It's because if you look at the next slide here, this is what a neural network looks like. So each of this circle here is basically one neuron, and this is a very basic image on a neural network. And the current deep learning network has like thousands of millions of neurons in the system. When we see the Rosenbelt, when he actually built his perceptron network, it's only consisting of 2 layers. And even now, we already have estimated of 3 layers here. You can see here. So the first layer here will be the input layer. The second layer is the hidden layer, and the final layer is the output layer. So this is basically the basic neural network simplified for you. Okay. Now, so when we talk about this, we want to ask ourselves, can AI solve all your problems? So if you're thinking that AI can solve all your problems, you are actually quite wrong. See, you say AI itself is a toolkit. So it's a toolkit in your how to say this? It's just a tool in your toolkit that you can use to apply what your desired usage. So the common misconception is that if you can just put data inside the AI model, any AI model, okay, and then you can just wait for the result, and then you will get your result, and you can just straight away use that result to do anything you want because it imitates the human brain, right? Actually, no, it's a very complex. It's actually more complex than that. And usually, if you just do something like this, your results are going to get garbage. You're going to get garbage result, and it's not going to work. So before you want to use AI to solve your problems, you need to understand why you want to use AI to solve your problems and how you can use AI to solve your problems. So now let's go through this next slide. So now we're going to talk about the basic structure of an AI project. Because AI itself is not basically a win all button. It has drawbacks and also has advantages. But but let's talk about that later on. But for now, so the basic structure of an AI project consists of the problem statement, where you define what you want and what problem you're facing, and then you need to identify the right AI tools and the method that you want to use. The third is data collection, where you need to collect the data, and then afterwards, after you collected the data, you want to train your model and you want to verify your test results. And afterwards, lastly, is to actually deploy your trained model so that you can use it for your application. So for my problem statement, I want you to ask yourself, what is the problem that you like to solve with AI? Because the thing is, when you think about AI, what is the significance of your problem that it needs to be solved with AI? Okay, why can't you use some other methods? Why must you use AI to solve this method? Because AI itself is quite heavy actually in terms of computing power. So if you want to use AI, you need to have a very strong justification on why you want to use AI, and not just because you can. You need to know why you want to use it. So you must always ask yourself, are there any better options out there? And what are the other methods that you can use for if you want to do like an AI project? And then afterwards, you need to ask yourself, do you want to do a supervised learning problem or you want to do an unsupervised learning problem? So you need to answer what category as well is your problem. Is this problem a regression-based problem? Is it a classification-based problem? Is it an object tracking-based problem? And so on and so forth. If you want to do image segmentation as well, you can. And as well as counting. For example, Professor Athif has already shared his some of the work that's done in the group, and some of it includes like counting cars and how the cars move, how the cars move in different directions, and yet you can still count them. And this is something that's very hard for humans to do. So that itself is a strong justification for you to use AI, because you want to monitor traffic as well as you want to count the number of cars that are available in the traffic. And this thing cannot be implemented by normal methods, because cars are coming in different shapes and sizes, and as well as they're moving quite fast. So you can use AI for this. So that's a strong justification for your problem statement. So always understand that you need to know what problem you want, and then how you can solve it with AI, and why must it be AI instead of other methods. So when we talk about supervised or unsupervised learning, this is quite important because this actually forms the basis of the learning. So for supervised learning, it's actually a learning approach defined by its use of labeled data set. So what it means is that let's say that we have a lot of data, and then we need to have something like category. So labeled data sets is basically what we will do and serve as our ground truth. So we want to classify this data into set outcomes. So basically, let's say that I have a group of animals. Okay, I want to classify the group of animals as cow, sheep, dog, cat. So you need to have a data set so that you're able to let the machine know that this is actually a cow, a dog, a cat. So you need to label those things properly and train the model first before you can use it and apply in the real world situation. So for example, I want to classify students in their respective group based on their test results, or I want to classify a student on their respective group based on their gender. So you need to have a data prepared showing the gender as well as the student. Okay. Or let's say that I want to predict the sales of my marketing team in 2025, right? Based on my performance from like 2000 and 2021. So all of this can be used, but I will need to label, say that, okay, this is my financial target for that year, and did I achieve it? And what was the actual financial performance? So all this you have to label in order to build a supervised learning based AI. So examples of supervised learning AI is decision tree algorithm, the K nearest neighbor algorithm, as well as our deep learning algorithm, the more popular one right now. So this is to better explain. So when we have our data, we want to label it here. See here, labeled data. So in here we have all the very different shapes such as hexagon, triangle, and square. So in this data itself, you need to label it with the labels, and this is what we call a data label. And this one will serve as a ground truth. So this data will be fed into the model for training as well. Sorry, this data will be fed to a model for training with the labels to reference the ground truth, so that the AI model is able to predict what's the object label. So after this, we will put some test data into the prediction. Okay, once we train this one, of course, you need to put the test data, basically the shapes, to predict and see whether or not this is properly predicted as a square and a triangle. If this thing is like square and then you put it inside and then it starts to predict a circle, yeah, it's gonna be some issues. So you need to, that's why you need to fix that later on. But we'll talk about this later on. But this is basically the idea. You have the label data, which consists of these labels, and then you feed it to the model for trading, and then the model will predict, and then the model will do some predictions, and then you can put your test data inside the model, and then it will come out with the results. So this is basically supervised learning. So unsupervised learning is an approach where we use the algorithm to analyze clusters of unlabeled data sets. So basically, you just put this, and then they'll try to group together the data so that to find hidden relationships between the data. And for example, if you use Netflix, you will know that suddenly you watch let's say anime, okay, or you watch Squid Game, okay, you watch Squid Game, and then afterwards it start to recommend you all those shows related to Squid Game, okay. So this is how Netflix has used its machine learning algorithm to actually promote the user for the shows that they might be interested in. Okay, so this is actually well, quite significant because this actually earns Netflix millions of dollars. And also we can talk about the Amazon or maybe it's Lazada or Shopee. You know, when you buy something, they always say that customer who buy item X also bought item Y. You know, do you want to add them in your cart? So you always see all these kind of promotions and whatnot from your online platform, online buying platform. So these are all examples of unsupervised learning where they use. So examples of this AI is a k-means clustering algorithm as well as association algorithm. So this is basically an example of how it looks like. So you have a triangle, you have a square, and you have a circle, and you pass through this algorithm, and then you group them together so that you group the triangles, the squares, and the circles together. Okay, so this one will be the basics for the learning. Now, oops. Okay, so when we talk about supervised learning, there's another group, and we call this as classification problem. So when we talk about supervised learning, classification problem is where we want to map our input data into distinct groups based on our class label. Okay, so for example, I have a big image of a cat, and I want to put this image inside the AI model, and it will actually predict whether or not it's a dog, it's a cat, or is it a duck. If it's a cat, then it will say yes, it's a cat. Okay, so this is an example of a classification problem where you want to classify something into a category. Now, another thing. Oh, so sorry. This is actually, I didn't fix the slide. This is actually a regression problem, not classification problem. So this is a regression problem where we want to predict a range of numbers or quantity based on the input data. So this is another type of problem. Please don't mind this thing. This is actually regression, not classification. I didn't fix it yet. So in this type of problems, you want to ask yourself, for example, how much is this property that you look at here, this beautiful house, how much is it worth in KL? Okay, if this property here, right here, how much will it worth in KL? Or let's say that I want to predict, okay, Apple, you see, 147.92 is going up, right? So how I want to predict the stock, this price of my Apple stock in, let's say, the future, let's say next year, I want to predict it. So that I want to know if I want to buy the stock or just like, I just don't care about it. Because look at Apple, it's like 23% of increase, you know. So if you put there, I will earn a lot of money, you know, just 20% by doing nothing, just by investing in Apple stock. So this is all classification problem. So sorry, this is regression problem. So for the regression problem, we take the house price as another example. Okay, so you need to put data about the house size, whether or not the house have a swimming pool, its location of the house, where it's located, maybe the age of the house, how many tenants have there been in the house, and so on and so forth. And this will be all our data. And this data will be fed into the AI model, and then the AI model will then predict the house price. So the house price can be a certain value from a series of numbers. It can be up for like 100,000, okay, 100,000 up to like millions of ringgit. So all these values are basically a fixed a certain number. So this one is classified as a regression-based problem. Okay, so next we need to understand is how you want to identify the right AI tools and method that you want to use. So when we talk about artificial intelligence, it's quite wide, right? There's a lot of aspects in artificial intelligence. The first one we talk about is machine learning, the neural networks. They even have robotic expert system, fuzzy logic, the one that you use in your washing machine, as well as natural language processing. So all of these aspect of AI. So today I'm going to talk more on this machine learning as well as neural networks. So give me a second. All right. So machine learning is where the machine learns through historical or previous data and then learns how to make prediction based on it. So machine learning is able to make predictions and decisions without being specifically programmed to. So we generally categorize this type of machine learnings as supervised machine learning, unsupervised machine learning, reinforced learning, and semi-supervised learning. But for the purposes of the talk, we are going to focus more on supervised and unsupervised learning. Okay. So one of the few machine learning techniques that we can use is we will talk about is actually the decision tree. So for example, here that we look at data that we have on students. Say that the student have age less than 30, like 31 to 40, greater than 40, and so on and so forth. So this is the age group that we have for the students, and we want to check their income. Let's say that your father is very rich, right? So your income is high. So if your family not so rich, then income medium. And I know if your family also, and also if your unfortunately family is poor, then we put it as low. So we need to ask, is this person a student? Okay. So if it's no, then we just put no. So this is here. So if the person is working, then he's a high income. Okay. Usually we see students, if it's no, they are students, so they are not working, so they usually have a low income. Okay. So the credit rating as well. So basically how much how much the bank will loan you money, and then whether or not you have a computer. So this is all the data that you can use, for example, to make a prediction. And this one, we're going to use it for a decision tree. So this decision tree, we use based on income to check first, see if you have high or low income. So if you have high income here, at age, of an age or distant age, it will like, it'll say whether or not you have buy a computer, yes or no. And it will actually go for the next one, where they call talking about medium, and then it will check student. Okay, if you're medium income student, whether or not you have bought a computer, then you'll say yes. And then you can even further go down towards the age group, and of course the credit rating. So basically this is a decision tree to actually uncover the hidden relationships of your certain decision. So from here we can see that, okay, if you're high income, most likely you will have a computer, right? High income above a certain age have a computer. So you can already discover a hidden relationship on that data. So this is how decision tree works. And the thing is, decision tree can actually go like very long, like credit rating, age, and whatnot. So sometimes you have to actually prune the tree. So just cut off certain parts of the tree that you do not want. Okay. So this is basically decision tree, and it's something that you can use for the data analysis. Another thing we want to talk about for this one, this is supervised learning, is the K nearest neighbor. So what happens here is that when we put the data into the K nearest neighbor, so we put this certain new data, a new data point into the data model, and then this data model will actually, and then the data model will actually compare, say that, okay, this K nearest neighbor, say that I set K as 3. So from here, it actually measures who are the closest targets to this data point. And then it will actually categorize it, okay? Categorize it based on the amount of nearest neighbors. So they say that, for example, I want to know whether or not this student, I say that, okay, he has high income and he has, for example, so here is income and here is age. So this thing will look at the categories, basically who and whatnot, whether or not they have a computer or whatnot, and then you actually compare them according to the distance. And once it's found, you'll say that, okay, if this thing has more neighbors here, it'll assign the data point to the category 1. So it will be here. So it'll become classified as category A instead of category B. Okay. All right. Another thing we want to talk about is actually logistic regression. And this one is basically using a sigmoid function to classify the student group. So let's say that I have this sigmoid. I put this sigmoid curve, which is what we obtain after the machine has been built, trained upon the data. And then it basically, anything below this sigmoid will be no, or it can be yes, depending on how we program it. And anything above it will be that's that is something that will be categorized as a yes. So logistic regression is binary, so it's either yes or no. And if you want to implement this for, let's say, you want to have like multiple classes, it will be called a multi-class logistic regression, where I attempt to draw lines across your data set, multiple lines across your data set. And yeah, the logistic regression is basically a sigmoid function trying to draw a line across your data set and to separate them between yes and no, 0 or 1. Okay, and the next one we'll talk about is unsupervised learning. So basically, unsupervised learning is the clustering group that we mentioned earlier on. So this is k-means data clustering. So we can see here, there's the original unclustered data. And then using this k-means data clustering, you try to cluster the data into this specific group so that we know that there's group 1, group 2, and group 3. Okay, so this is k-means data clustering, and it's unsupervised learning. It doesn't produce exactly a result, and it just groups them together. So it doesn't make decisions, but it gives you results that you can interpret later on. Okay, now another tool I want to talk about is deep learning, and you can see here this is a deep neural network. All right, so I want to put your attention here into the first layer. It's called the input layer. Here you can see all the neurons align on here, and this is where we first put our data into the neuron. So this is what we call a new input layer. And then the last one will be the output layer, where it has the activation functions for the output layer. And this thing is basically the front and the back end of the neural network. So in between here, we have the hidden layers. Okay, so you see here we have 3 hidden layers: hidden layer 1, hidden layer 2, and hidden layer 3. So when we talk about deep learning, okay, so we ask ourselves, what is deep learning, and why is it so special compared to the normal neural network? And basically, in simple sense, is that deep learning is just we have more hidden layers. So a normal neural network will only have 1 layer, and a deep neural network will have multiple hidden layers. So you can see here. So here has 3 layers. That's why when people say that you need to go deeper. So they actually put more hidden layers in their design. So you're gonna ask me if more layers, is it better? Answer is not exactly as well, because the more layers you have, the more chances of the data to get overtrained, or the deep learning itself will interpret differently on the data. So this is something that researchers are currently researching about, and it's very hard for us to understand how the AI works, because once you go through the first layer, it goes through the second, third hidden layer. How the AI interprets the data, it becomes very hard for us to understand. It's beyond our understanding already. So a bit of introduction, explanation on how the deep neural network works. So first, we have the data and it's fed into the network. So we call this process the feed-forward process. So this data will feed into the input layer, goes into the hidden layer, and then it passes through the output layer. Okay, so once we pass through the output, it will produce an output that you will need to compare to the ground truth. So once you compare the ground truth, it becomes an error. So we call the output error, and this thing will be feed back towards the neuron. And this is what we call backpropagation process. And this thing will feed back to the neurons in the hidden layer. And part of the feedback here is that the rate and biases that we see previously, it should be updated in all the neurons there. So this process itself will keep on updating the neurons every time you do this. And it's essentially the way that the machine learns from its mistake. That's why we put this as a machine is learning. So basically, it's always constantly updating its weight and biases in the neuron. And when the data is fed, when all your data in your samples has been fed, and we call it has completed an epoch, and then you will go to the next epoch. So the more epoch you have, okay, so you can define as many epoch you want. So you can pass through how many rounds of your full data, pass it into it, and then you'll pass back. Okay, so you can define as many epochs as you want, but you need to understand, the more epochs you train, the better model will perform. However, too much and it will cause an overtrained model. So basically, we'll talk about this later on, but basically the model itself, it's trying to fit the curve, the signal function that I showed you earlier on, it's trying to fit the curve too much, and it becomes too trained on that particular data. So you can use the deep learning network to perform classification and regression problems. Okay, so that's not an issue, but you need to understand. You need to define the certain amount of epoch as well. So the question now you might ask yourself is, hey, if I have an image, right, can I use this deep learning this deep learning network, right? So the answer is yeah, you can. It's not a problem. You can use it, but it's going to be very slow because if you put your image data into this deep learning model, you might not realize it, but our image has a lot of data, and you want to feed all of this into the neural network takes a lot of time, and so it's not very optimal. So what are the options available? And the answer here, the researchers from data scientists, so they found out that there is another method that they are using, and this is called a convolution neural network. So this is the convolution neural network. All right, how this works is basically, you see here, the input image. So if you have your image, it consists of red, green, and blue. So the image that you see right now on your computer screen actually consists of red, green, and blue channels. And this input basically there will be a small window, sliding window, will go through all these channels, and then it will go through this process called convolution, where you try to extract information from your image. So this information will be extracted from the image, and it will become smaller. And you can see here in this next one, convolution plus ReLU. ReLU is actually the activation layer. So activation layer will basically something like this, the one we see early on, the sigmoid curve. So it will only accept inputs that fits its criteria. Okay. So for this thing, it'll take the inputs and it'll try to extract features from the image, and with the process of convolution. Okay. So once the image is extracted and it goes through the ReLU activation layer, it tries to pull the data. So what pulling does is basically it picks the highest data and tries to shrink the data to another smaller cube. And you can see here. So from here, convolution, it becomes a lot smaller, almost half the size. Okay. And this pool images will be further go through another convolution layer, another pooling process, and so on and so forth until it becomes a small flat cube. So the reason they want to do this is basically because they want to reduce the amount of data that you want to fit into the neural network. Okay. So this data you can see here is then flattened. From the image, is flattened down into flat data, and then it's sent into the fully connected layer. Fully connected layer is basically the neural network that we've seen earlier on here. So you just feed it inside this fully connected layer, and then it goes through the softmax activation function, where it'll categorize this object as a car, truck, van, so on and so forth. What type of object you want to categorize it. So basically, it has this convolution layer in front, convolution pooling layer in front, that will help to shrink and extract information from the data, from the picture that you have, and then it goes through the fully connected layer, and then pass through the softmax. Here's the softmax, basic activation function, to identify whether or not this is a car, a truck, a van, a bicycle, and so forth. So the idea here is that I want to make this thing smaller. I want to take only the important parts of the data, and then I feed it into the neural network. So there are many types of convolution neural network architectures, such as AlexNet, VGGNet, GoogleNet, ResNet, and so on. And each of these net has different models and different advantages and disadvantages itself. So this one, you need to go through it and understand which model you want to use for your application. So this is VGG16. Bit of it's architecture. Okay. This architecture of VGG16, you can see it's very similar to what we see from the previous slide, right? Very similar. You can see here you have a pooling layer, convolution layer as a pooling layer, and then go through another two convolution layer, which is different from the one that we showed us now because it's a different architecture. Okay, and then another pooling layer, convolution layer, pooling layer, convolution, pooling, convolution, another three convolution layer, another pooling, and more fully connected layers here to actually interpret the data, and finally the softmax activation function. So this is the architecture of VGG16. Still quite similar to this architecture, right? It's just slightly changed so that you have more convolution layers and whatnot. So, but if you go to another one, you go to GoogleNet, for example, and you see this this complexity has increased, and they actually modify this architecture even furthermore. And you can see this is also the same for other types of architecture for the CNN. But how they work is actually the same. The concept here is the same, but it has pooling layers, convolution, as well as pooling layers to extract information. before it's sent to the fully connected layers to interpret the data. Okay, so this is just image extraction process. Okay, so in a nutshell, you need to know what you want to use AI for, and you need to know the different AI methods that are available to you for your usage. And of course, you need to understand the various AI methods and which one is suited for your application. So this is the very important thing that I would like to share for you when you want to select the AI you want to use. Okay, next one you want to talk about is actually the data collection process. So you need to talk about your data collection process because it's very important. The most important thing for your AI project is your data collection to make your database. So if you want to implement an AI, it requires massive amounts of data, like really, really huge amount of data. So you need to collect the data to make a very successful AI program. So actually data collection itself, right, is a huge business. So there are startups that we have a youth that make millions, suddenly become millionaires just because they build a company around collecting data and they sell the data to other people. And this happens in the US, of course. So if you are, like I said, that you want to be an entrepreneur, you could actually consider this as your one of the possible ways you want to move. So who knows? Maybe you can become the next millionaire. Suddenly you open a company for data collection, and then this data collection is tailored for AI. Suddenly a lot of people will buy information from you, and then you become richer. So the thing about data collection, however, is that it needs to be accurate and it need to be relevant to the particular outcome. Okay. So for example, let's say that I want to determine the price of the house, right? I need to know about the house size. I need to know about the house size, the house, let's say that the house whether it has a pool, its location or whatnot. I don't need to know whether or not the house has a dog or a cat. I don't need to know whether the house has a dog or a cat, whether or not whether it has a dog or a cat, whether or not it has access to the mall or whatnot. Maybe those are quite important, but some of them might not be as relevant as others. So you need to make sure that your data is relevant, and you need to have around of a minimum for this type of data. For this database, you need at least 1,000 data samples for regression and classification problems. So you need to take this into account, and it's actually one of the more painful process of making AI. It's actually because the data collection takes a lot of time and a lot of work. So the previous one I talked about is data collection for something that says that you want to build a house. For example, the first slide I have. Let's go through that. Yeah, for example, this house one. So this one will be what we call as the normal class regression problem. Okay, so these are all data, and it will look something like this. Let's see here. They look something like this. So this one will be all about data, but let's say that I want to have images. Okay, let's say that now you want to do AI that extract information for images. So for this case, you need to have a proper image database. So each of this category in your image has to have a minimum of around 300 to 400 pictures. And this image has been taken from various different position and perspective. And it has variable features in the image, but you try not to have foreign objects inside of it. And you don't want it to heavily be distorted, blend the background. And because why? It's because it makes the AI very hard to differentiate and learn from the image. For example, you see here, first one, you see the cat, very adorable cat, right? Very close, very clean, very neat picture. So yeah, this is actually the image that you want. On the second image, however, you see a human trying to kiss his cat. So yeah, the AI might have problems because it's actually trying to look at a human being as well as a cat. So if you don't have a human in your training, so try to remove this. You can just cut out the human. So you just put the image of the cat so that the AI can learn from the image that this is a cat. I don't want to know about this human thing. And lastly, of course, is this picture where you can see a cat in the background of snow. So this white cat itself, you can see, is very hard for us to actually identify the features on the cat. You see here. So the cat is very well blended in the background, so you can't see the cat properly. So the AI itself, will have problems trying to identify the cat from the background. So try to avoid pictures such as this. So how do I make an image database? For example, let's say that I have my cat, okay? Images of a cat. I need to create a cat folder and put all my images of the cat inside. The same goes for my dog folder. You need to put all my dog images in one folder. the dark images in one folder, and the sheep images in one folder. So each of this folder will contain around 500 images. So you see the cat here will contain 500 cat images. The dog one will contain around 500 images. The duck around 498, and the sheep around 501. So usually, as a good practice, we want to make equal, okay? So the cat, the dog, the duck, and the sheep should have almost the same amount of images that it has. So if the best practice is to have 500 cats, 500 dogs, 500 ducks, and 500 sheep. So try to make your images balance so that the AI can learn from the image as fairly as possible. So the next one I'll talk about is model training and verification. Give me a second. Okay. So when we're actually trying to do model training, we need to split our data into training and test data sets. So as a normal practice, we usually split our training data set into 70% and 30% test data. So when we do a train data, when we have a training data, it's basically the data that we want to use to train the model so that the model can study the data. And it will study the data, extract features from it, and then it will be able to produce a trait model that is able to interpret the result. The test data that we split is what is going to be later fed into this train model so that it can gauge the performance of the model. So we want to avoid overfitting so that the model doesn't go and just look at the train data and then say that, okay, I will follow this data 100%. And then when it goes down to a real situation, it will not be able to properly understand what it is actually, and it will give you a lot of errors. So this is an example of to better explain to you what we call underfitting, overfitting, as well as the optimum curve. So when we have underfitting, basically the AI model is unable to properly fit the data. So it's unable to draw a proper fit. So you can see here, it's unable to fit between the star and the circle. So some of the stars are fitted on here. So this one will be an error, okay? Or everything above here will be a circle, but unfortunately there's a lot of stars here. So this model is not properly fitting the data. So you're gonna have a lot of training error and a lot of test error. So this is what we call a high bias model. So this model is underfitting, it's underperforming basically, okay? And the next one we're talking about is actually the optimum one, where the AI model tries to fit as much as possible, you can see here, but not too much. So it has low training error, it has low test error. It has some errors, you can see, but the AI model tries to fit as much data as it can to categorize them into their respective category, okay? And then last one we'll talk about is overfitting. So you can see here, the AI model has drawn a very beautiful shape, very beautiful curve to fit all the models that we want here. You can see even here, the circle here has been drawn. But this thing only makes it that it can be used in the low training error situation. But when we put it in a real life situation, right? Real life is not going to have this same model. It's going to be a bit different. And it will still use this curve to be used to interpret real life data. So what happens here is that it's going to have a lot of errors because this thing has been trained to fit my training data, which is something that we did in the control environment. And real data is going to be different. So the best thing you want to do is to put it optimum so that you have some amount of errors, but not too much. So yeah, so what happens here for overfitting is that you're going to have low training error and you're going to be high testing error later on. So when you deploy this overfitted model into a real life, you're going to have a lot of errors. For example, you categorize a duck as a cat or a cat as a dog. So this one we call an overfit model. And this is also a high variance model. So the term for this is high variance model. So example of the error versus this thing, iteration. You can see here, this is the training set, the training data for the error. And then for the validation data, okay, you can see, so it's underfitting, you see here. This is what we call underfitting. It's not, the error is very high, but it's not that high, okay? Still not that high. It's still trying to follow the curve of the training data where we feed the validation data set into the model. But as it goes through here, as it trains from a higher number of iterations, it starts to going up, you see here. So why? It's because it's overfitted. is the model has been trained to go through this training data. Has been trained too much to follow the training data that is unable to generalize the a different data set. So you actually see more error here. It's just starting shooting up. So this is how you can identify overfitting and underfitting in your model. So the last one we'll talk about is model deployment. So once you train your model and you verify it, you can now save your model and you can deploy your trained model to your desired application and platform of your choice. So this process itself is quite hard because you need to build your UI, you need to build you need to then transfer this thing to build your application so the application can actually work together with your machine learning model. And this is actually the harder part. But we will not go through this later. You need to you will need to exploit yourself. But I have a simple solution for you. So this is called the Creator Suite. So this can be accessed here, the Creator Suite. So it's basically an online platform for your AI creation. It's a much easier tool for you to use, and you don't need much programming. And you can go through this website here. This is developed by the company called SkyMind. I have received the permission to be able to share this platform with you. So you can just go through here, register it, and then you can save your model and then put it inside this platform, and it will have something like a dashboard for you, so that you can just straight away deploy your AI model without any fuss. So this online dashboard allows the user to upload model to its cloud, and then you'll automatically set up the dashboard according to your desired settings. And this dashboard supports frameworks such as Onyx, TF, PyTorch, and Keras. TensorFlow, basically. TF is TensorFlow. So there's a lot of platforms that you can use for your AI. Some of them such as Deep Learning 4J, which is for Java, TensorFlow and PyTorch, and Keras for Python. Onyx, I'm not too sure because I don't use it. But you have a lot of platforms for you to use, and this Creator Suite is actually compatible with all of them. Okay. But unfortunately, there's some issue with the Creator Suite, so I cannot show you guys how it works. But you can visit this later on because currently the Creator Suite has some problems in the system. So it's not fixed yet. But hopefully that once you finish your pitching or whatnot, you can try and use it later on once they fix the problem. So another thing I want to promote is actually there's an AI GET program from SkyMind company. So this AI GET program is 15 days face-to-face training and 8 days of virtual training. And it's a program that helps you get started in your career as a data scientist, AI engineer. Okay. So there'll be 15 days. You have to do face-to-face training in Menara SkyMind in Penang, and then 8 days of virtual training in your platform of choice. Okay. So this one is like a scholarship for 25 Malaysian graduates. So you need to be graduating soon. And then you need to be graduated. You need to be graduated, and then you will have a starting salary of 2,000 to 4,000 ringgit. And this is a 2 months intensive training period, and it will give you a job guarantee once you enroll into this program. Okay, so the period of this program is from 13th December to 10th of February, and you can register here through this QR code or through this website. I will share to you the poster later on in the group, as well as email them to all of you if you're interested of joining. So there's actually a rigorous screening process, but yeah. So because this is actually a job guarantee, so they're actually looking for potential students to join their team. So you can contact them here at talent@skymind.com or their website, SkyMind Education, or their Facebook page or their TikTok page if you want to know more about this program. Okay, that's it for me.
Okay, thank you very much, Winsun, for your insightful session. And I believe everyone who don't know AI may be having more understanding of how AI works and how the thing behind of AI, because people will just hear AI without knowing the details of AI, but then it's more like an overview. Still, it's an overview, and you can use the platform available to use to check for this AI function. Okay, we're going to share with you the link. Okay, Winsun, I think we have a new link. Sorry, not the link that Winsun gave. Winsun, can you please? Yeah, we have the new link. Sorry.
Okay.
Okay, if you enter this link that I share, you are going to it is quite similar, just that we are now linking it with a direct certificate. So you can fill in the forms and then you're going to get your certificate directly to your mailbox. Okay, if you are UTM staff, you can fill in your UTM number. But if you're not a staff or student of UTM, then you can just omit that area. So I think we can open for Q&A. While waiting for Q&A, can we have our photo session together as we are attending this MEITA? So our speakers semua pakai background yang sama aja. But then if you want to join us, just click at the change virtual background. You can select the mangrove tree tu. But then it's just an option. Okay, so for those who are available, boleh kita ambil gambar. Siapa yang tak available tak apalah so now we have 5 people. Okay, ada yang nak join? Thank you Syahmi. Kalau tak ada, saya ambil gambar yang ada je lah Okay, thank you Khairi. Anyone else? Okay, kita ambil yang mana ada gambar dulu and then kita akan ambil gambar dengan nama semua orang Okay, 1, 2, 1, 2, 3. Okay, ni saya ambil gambar semua orang. Kita ada 38 orang hari ni. So that your name will be around. Okay, okay Hafidz. Okay, Hafidz dah join. Okay, thank you Hafidz. Sekali lagi saya ambil sekali lagi. Sekejap Ada lagi nak buka kamera? Okay, kita ambil dulu. Okay, 1, 2, 3. Okay, ni kita ambil ramai-ramai. One more. 1, 2, 3. Okay, second page. 1, 2, 3. Okay guys, okay, so kita buka any question from you? Ada soalan tak? Thank you Khairil tadi komen sama. Okay, what will happen if we have less data? So biasanya akan jadi less accurate lah. Okay, less accurate meaning chances of getting the data better will be not good. Okay, ada question how about the AI in Malaysia?
Can I add in for Shami's question?
Yeah, sure. Silakan.
Actually for
Hazwan is doing AI punya research juga.
For the samples, actually it's according to the complexity of your problem. So then there is a method of identifying how many samples you need by using a low number of samples first and then checking your accuracy. So if your accuracy is your test accuracy is enough, then your test accuracy is enough, then you can stop adding the samples. But then if your accuracy is low, then you need to add more samples then, and also add more variety of the samples. But then always make sure that your test accuracy is in par or maybe higher than your training accuracy, because if your training accuracy is high but then your test accuracy low, then this is also another way you can identify that you are overtrained already. So that's my addition to the answer. Okay.
Okay. Thank you, Hazwan. So, is there any more questions? You can unmute your mic. Okay. We have a question from Shami Fahan. So he want to ask, how about AI in Malaysia? Is it have the right right future? Doctor, would you like to answer this?
Um,
Or Hazwan want to answer this?
okay,
Yeah, go on,
this
go on.
is my perspective from industry perspective. Okay, so in Malaysia, we have a lot of companies that are located outside of Malaysia, very big companies, let's say like Dyson and even my company. So at the headquarters, they are already starting to do all of this, and this is now being implemented to the sub in Malaysia too. So I would say in the in the near future, a lot of companies will be using this AI, and because I think because of Industry 4.0, everyone is racing towards using AI in their respective companies. That's from the industry side. Any others would like to add in?
Yeah, give me a second. Okay. So I want to remind everyone to fill in the form because we will need this data to produce a cert for each and every one of you, a certificate of participation. So do fill in the form that with the link I sent to you just now. This one, the new one, not the previous one I sent to you. So make sure you fill this in. Okay. So to add on what Hazwan said, there are our government itself is promoting AI. One of the companies that are doing training for graduates is SkyMind, the one I shared to you previously. So if you're interested, you can contact SkyMind and then ask them what are the available programs that you can join to improve yourself in AI. And currently, our country, Malaysia, has a lot of programs because they're trying to recruit as many people who is good in AI in the industry, so that our country is AI focused in the future, and as well as how to say this in terms of industry, the AI is being implemented in a wide range of products, such as test and measurement products. So basically, where you have wafer fabrication, when you want to determine whether or not this wafer has issues, it also uses AI as well as the testing. So AI is widely used in Malaysia as well, but it's not as how's it this you won't see this too much because some of them considered as trade secret, so they don't really share their AI development. But it is being used in wafer fabrication and testing.
And if you go to Job Street, if you type AI engineer or data scientist, you will see that their salary is more actually than the normal industry engineer.
Yeah. Even banking itself are looking for AI engineers, even in the banking sector. So yeah, anyone have any other questions? You can just unmute your mic and you can ask us. Yeah. You can ask not limited to AI. You can ask about the previous sharing as well for robotics. Okay. If not, give me a second. Let's look through this one. The next one.
So we wish you good luck for your hackathon, and all the best for for the team. You can look at the suggestions that we have given you, and I believe the IoT group will also be sharing their thoughts on and to guide on IoTs. So our part will be on the project formulation. That the topic of project formulation can be applied for all. If you're doing on IoT or you're doing on robotics or AI, it is applicable for all kind of projects, not only even for this competition. So for example, if you have FYP projects, master project, and any industrial projects, you can also apply what Hazwan already shared. I already fill in the link just to test, and I get already my certificate. So for those who haven't filled in the form, you can fill in and directly it will be emailed to you. Winston, I think we can close the session if we don't have any other question
Oh,
or
we
comment.
actually have a question. Give me a second, doctor. I just saw this one. Okay. From Kyrie Azrul. Are you asking, will the dataset shared to participants? It's actually not very clear. Can you explain this further? Kyrie Azrul. You can type inside, or you can unmute your mic. Will the sample of the pig? Sorry, I don't understand.
I think from what Khairi is asking, any data set that we are going to give based on mangrove, for example, or any data related to mangrove
No.
ecosystem.
Unfortunately, no. If you want to do an AI, we will not be providing the pictures for you. Yeah.
So to relay what Winston was mentioning, I think for the data set that you want to go for, whether it is a flora type or fauna type related to mangrove, yeah, we are not going to give you any of this data set. But then you can search for available data set. Okay, GitHub, maybe if there are some available animals or maybe creatures related or trees. So you can refer to, and hopefully you can do that as part of the project. Okay.
Yeah.
Okay, we have another one question here. Okay, sorry. This one was given to me. Is there anything we can do from robotic side or technology or IT sensors to detect the absence of trash at the remote area in the near to mangrove? I think one of the idea that we can also look for is on the trash, okay, rubbish ke ataupun any bottles where close around the riverside, where this is going to be affecting mangrove ecosystem for sure. Because when we went to the previous site in I think in Sabak Bernam last time, we can see that a lot of trash are available and we have to clean. Okay, so if you have a solution to do cleaning or maybe doing detection, so I believe it will be a good proposal, okay, for us to see how it can be solving these issues. So in terms of detecting is one thing, but then in terms of doing the cleaning process, if you have those solution, that will be also a possible idea that you can propose. One of the way is, for example, if we have a static camera or a static sensor, then we can inform the user or maybe some penduduk di certain area that we can come and do cleaning process. So it's like an informing solution also possible, because kalau kata kita nak deploy a drone or to do cleaning, mungkin it will be a quite futuristic punya solution lah, because at the moment mungkin agak mencabar. But then if you have this kind of idea where you can inform somebody to do the process, or maybe to inform if you have a thorough density of trash, okay, so maybe that will be part of alarming. So you can decide category A sikit sampah, category B medium, category C banyak. Mungkin bukan sampah saja, any impurities lah we can say. So that will be also a possible solutions that you can highlight. But one of the thing is, if you can support or you can back up with available inputs and somebody who are working in the mangrove area can support. For example, you can cite, katakanlah Professor A who is doing in this mangrove was highlighting this. So that will be a good support to your problem statement. So it's not just coming out of nowhere. You have a link of website, you have somebody that you have interviewed. So you go back to the empathy side which Hazwan was highlighting to clarify clearly this is a problem. Okay, so that will be a good way of presenting later. And if you can put in some more statistics, katakanlah out of 10% of mangrove area, so 99% issues is coming from crash. So that kind of justification will be helping in your pitch later. Thank you very
And
much, Photographer.
to add on, just now you asking for the sensor. Yeah, maybe you can add this in your black box analysis, and then do some options for the process of detecting the trash. One of them maybe can be using a drone and camera, right? Using drone and camera, and then image classification to classify how many trash is in the picture.
Yeah. Okay, I think we are sharp at 12 o'clock, and I don't want to prolong this session. If you want to send the attendance, you go for the final one, this one. So you go for the link that was provided later, okay, at 12 o'clock ni. Because the link is, I mean, the first one and the second one is similar, but then the second one, we're going to give you directly certificate of attendance. Okay, so go for the second one, you fill in and you can get the certificate later. Okay, with that, I think we can end the session. I would like to thank again Mr. Hazwan, Vincent, for arranging many things for this session today, Mr. Ridhwan, and we have also Secretariat for MEITA. We have Maya here, some other Secretariat joining in. Thank you
Fatin
very
as
much
well.
for Fatin as well. Yes, thank you, Fatin. And all the members who have contributed time. 3-hour session is not easy. And I believe the speaker as well, they have prepared slides as best as they can to provide the sharing for you guys. And hopefully we can gain something out of the session. And yang mana kurang, we hopefully ask for your apology, and the thing yang mana bagus, I think it will be good for you and for me to learn together. So with that, thank you again. Assalamualaikum warahmatullahi wabarakatuh, and all the best for your competition. Okay.
Bye.
Bye-bye.
Bye, everyone.
Okay, bye-bye.